Okay, so power is something we need to worry about here. Power is the rate of doing work. So I can do exactly the same amount of work. I can lift my bottle from here to here, or I can lift my bottle from here to here. I've done exactly the same amount of work, but one of them I did a lot faster than the other one. And the measure of how fast you do work is what we refer to as power. So power is simply the rate of doing work. Okay, so on your formula sheet, you'll see power is work done divided by time taken. And so the longer you take to do the work, the less power you have going on. Okay, so the units, W is work, which we've already talked about as being in joules. Time is in seconds, and power, any takers for the unit of power? Light bulbs measured in watts, exactly. Which just adds to the confusion of W's. Okay, so capital W can mean weight or work or watts. Okay, so work is W, power is P, but the unit is W for watts, just to add to the confusion. Okay, so a load of 500 kg is lifted through 7.5 meters onto a ship. The crane takes 45 seconds to complete this. What power is the crane working at? That's the sort of thing which you may need to be able to do. Again, I'm ignoring friction, I'm ignoring inefficiencies in the crane, all those sort of things. Again, as mechanical engineers, you'll learn about all those sort of things, and you'll never assume that you've got a 100% efficient machine, but at this stage we're going to ignore all those sort of things. The old spherical chicken in a vacuum. And we're going to just go with some basic assumptions and see what we come up with. Right, plan of attack, what are we going to do? First we're going to find the force. Okay, so let's find the force. So how are we going to find the first force? Yep. So the force is weight, isn't it? Mass times gravity. So 500 times 9.81. What do you got? Let's see, buttons have been pushed. 4905 units. Not kgs, this was kgs. Newtons, awesome. So the force is in newtons. Then we're going to find out the work. Okay, so which formula are we going to use to find out the work? Force times distance. So the force is 4905. Distance is 7.5 meters, which gives us, who's pushing the buttons this time? We got Nathan. 37125. Okay, can dispute. I'm sorry that lost out. What's it else? 36787.5. Yep, that's cool. You guys as well? Yep, awesome. Units for that one? Joules, because it's work. Yep, awesome. Power, work over time. So 36787.5 divided by 45. So you get 8. 817.5 watts. Yep, so 800 watts. Make sense? Yeah. Okay. So that's the sort of question that you're going to have to be able to deal with at this stage. So again, the question asks about power. The only formula you've got for power has got work and time in it. So you're going to need to work out the work, which you can either do by work as force times distance, or you could have said how much potential energy is it going to have at the top, and that's the amount of work I have to do. So you could have just gone straight to potential energy, being mgh, and you got the same answer. But the way you chose to do it was force times distance, and so you had to work out the force. And it's exactly the same thing because mg and S is h. So work is just mgh, exactly the same. So you could do either. Think about it either way, but the answers are exactly the same. Work is force times. Yeah, and also it works for things that aren't gravity. So if I'm pushing a car along, so my car's run out of gas and I'm pushing it, how much work am I doing? Well, nothing with gravity, but wherever the force is I'm pushing it out, so friction basically, times the distance I move it, gives me a measure of work. Okay. Yeah. Whereas if there's a train coming down the track, well, there's a train that's on a big hill and it wants to run down the track and run over something at the bottom of the track, and I do my Superman impersonations and I hold the train from moving, how much work am I doing? One answer is a lot. The scientific answer is, so the train's stationary, not moving, but it wants to move and I'm just holding it back. How much work am I doing? Now, the force is equal, so my reaction force is equal to what the train's pushing with. How much work am I doing? Nothing, no work. No distance, no work. Okay? Big force, no work. Okay? Work has got to have a movement to be considered to be work. Work is force times distance. If there's no distance, I'm not doing any work. Okay? Huge force, can still have a big force, but no work being done. Okay? Which means no power. Okay? So just because you've got a big force acting doesn't mean there's any power going.